with no further ado, let's bring on Jack Kappa. Yeah, there's stickers over here, so check it out later.
Get the stickers. Hi, everyone. Thank you so much for coming. Like Ben said, my name is Jack. I'm at Politico right now, and we do a decent amount of Vue, and I had shipped a number of Vue projects with people talking about potentially adding TypeScript to them. Starting with a project about 2 months ago, we decided to implement TypeScript on a project, and I want to talk about some of the lessons learned, some of the why, and the what TypeScript is and the how, and then very importantly after that, so we're shooting for about half an hour to 45 minutes of just kind of this intro to TypeScript. After that, we're going to do a workshop together. I have kind of a simple Hello World app with just a couple API calls. That's linked in the Discord channel, and we're going to take a look at how that works right now briefly, and then we're going to get started converting that to TypeScript and try to work through some of the hurdles together, and I'm sure many things will go wrong, and we'll figure it out, like developers. The first intro question, who has heard of TypeScript before tonight? Cool. And who's used it in a project? Awesome. And are those, for those, raise your hand, used it in a project, have you used it in production for your work? Cool. Yeah, we can switch back to that real quick. Yeah, no problem. Just to review here, so we've got the Wi-Fi password up here, and you can find a link to our Discord where we're going to be sharing some links at that Vue.dc.io. Cool. So very many have heard, maybe half have used, which is perfect. We want to talk about why it makes sense for apps, why it makes Vue better, or why it makes JavaScript development in general better, why it might be popular. And then before we get into the workshop, we'll talk a little bit about the Vue specifics with TypeScript. Anyone else need this right now? Cool. All right, so the breakdown of this lecture portion, we're going to talk about why TypeScript exists. It's enterprise JavaScript. We're going to talk about what it is, static type checking, which is obviously not the way JavaScript was normally designed, but as projects get bigger and more complicated, we find lots of uses for static type checking. And then finally some how, with some quick basic demos of some of the basic functionality that makes TypeScript work the way it does. This is kind of the bare minimum, is that you have your sample.js file, and all TypeScript it's called a superset of JavaScript. So any JavaScript file where you just change the extension to TS is automatically a valid TypeScript file. And TypeScript can do some fantastic things, which is that I want this some string to be a string, and in JavaScript I'm never going to get yelled at for that because JavaScript doesn't know anything about the types of my code and what types are allowed to be where. But TypeScript can infer, and you can tell it that this thing needs to be a string. And so we get a lot of compile time and build time errors that can show us where code might be wrong before it makes it to the browser, especially. And this is also used in Node too before it, gets deployed on your server. Another quick example is what TypeScript gives us in a code editor, or some people would say an IDE, but in VS Code here, you get a ton of information about the code that you're interacting with. So you get autocomplete because TypeScript knows this is going to be an HTML element. It knows the available options, and it also makes sure that this thing exists before you try to access it. Just really useful and ways to speed up your development process. And finally, when you have your own things that you've created, you can tell yourself, for future reference, you can tell new people coming to your code, hey, look, these are all the members that are available, or these are all the methods that are available on this thing, and these are the arguments that it expects, and you can give lots of information, really, really good self-documenting code. So kind of what we've talked about here, the benefits are better type safety. Is this variable what I'm expecting it to be when I'm interacting with it? I no longer have to guess. More accurate code, because no longer are we interacting with just strings and hoping that we've typed them correctly, for example, as we're trying to access a method. we can actually be told by the code editor, these are what's available, and if I type it wrong, if I type it with 2 T's, TypeScript will tell me it'll fail to compile. It'll say, fix this thing because it's not what you expect it to be. Self-documenting code is a huge one for teams, I would argue, and just for anyone who comes back to your code after 2 weeks, because you generally forget most of it. So by telling yourself, this is what I'm expecting here, and this is what it's outputting there, and doing that in code rather than in comments, you get really maintainable code for teams. IDE help or VS Code, which is somewhere in between. And then I would argue the quicker onboarding, which we've definitely seen in the project that I mentioned, which we've been doing for 2 to 3 months now. 3 developers that were brand new to TypeScript. Obviously, there's a few days of learning some of the syntax, but then from that point on, people are able to pick up code and see exactly what you intended based on the annotations that you've provided. I do not have a computer science background, which is great in front end, is that I think we have some flexibility with that. But this is where you get into a little bit, hi, welcome. This is where you get into a little bit of the decision making that goes into programming languages. In types for programming languages, you can have dynamic types, which is Python and most importantly to us JavaScript, where the type of any given variable is checked on the fly as it's executing and making sure that, hey, is this variable what I expect it to be? A lot of lower level languages and what we think of as backend languages are all statically typed, which means that as I'm writing it or at the time it compiles, the machine makes sure that types work, so you don't get code that's then sent somewhere where the types aren't going to match up. And so that's essentially the void that Microsoft, when they created an open source TypeScript, was trying to fill when you have larger scale projects that you want to know with confidence.
Microsoft created TypeScript, I didn't know.
Yeah.
We don't use it. So.
Yeah, Microsoft, I think I have history here. Yes, cool. Next slide. Open source by Microsoft in 2014. I would argue, granted my background is not super back-end, and I know there are lots of things that Microsoft did poorly,
Yes.
but I would argue that TypeScript and obviously VS Code are 2 open source projects that yearly now are dominating popularity contests essentially on GitHub because they're just joys to use, and Microsoft has supported them incredibly well. VS Code, so the other big open source project, is written in TypeScript, which is why it works one of the reasons it works so well when you're developing TypeScript applications. I think a huge reason that TypeScript has the popularity it does is because Angular 2 plus, everything after Angular 2, was both written in TypeScript and expected you to develop in TypeScript, meaning that people often got their first exposure from having to create a class and create a component and use interfaces. And because it worked well for large teams, I think that was a big boost behind its popularity. So that was Google using Microsoft. Now Microsoft is using Chromium. We're all happy, right? We're all happy. Who needs more than one choice? At the time I wrote this, it was big news that Create React app, so the essential, if there is such thing as an essential React application or starting point, had added a TypeScript option in October, and that was really big news. And then Vue 3, so we can start using it right now, which is great. We can use it in our applications, but Vue 3 is going to be written in TypeScript, which is cool. The expectation is that the Vue we're using right now will not change much in the way you interact with it. They're keeping, from most expectations, they're keeping most of the API, the publicly available parts of Vue the same, but their source code will be entirely rewritten in TypeScript. I think I have a quote later from Evan about some of the reasons they made that decision. But you can use it right now, and what we'll be doing in our workshop with any Vue application, but especially with a Vue application generated by the CLI, it's extremely easy. this CLI plugin for TypeScript allows you to generate a brand new project with TypeScript. That's actually not what we're going to be focusing on in the workshop, because I would argue that's extremely easy and also a little bit rarer, where you get the opportunity like we had with a new project starting, where you can start fresh and say, yep, I'm going to initialize my Hello World project and I want TypeScript from the beginning. So the thing that can be a little bit frustrating is the other case where you want to add it incrementally. Because, like I said, any JavaScript file is valid TypeScript. That process isn't too difficult. We're just going to talk about some of the Vue-specific hurdles. So this is all you do. You say language equals TS. And as long as you have your build properly configured, Vue will just build. They need to obviously first compile from the TypeScript that you've written with extra types and compile down into JavaScript, or transpile to JavaScript. Oh yeah, this is from Evan. The highlight here: we believe the type information IDE support will actually make it easier for a new contributor to make meaningful contributions. This was a big justification for us in trying it out in a new project, even though there's some learning curve to get started. Okay, and now the how. We want to look at just, you may have seen something similar in other presentations, just at its most basic level, what do I have to do to use TypeScript and get something out of it? We're going to look at a few of the basic things it provides. So in review, this first thing that we saw is when we changed to a TypeScript file, it already knew, based on our code, it could infer the type of our variable. It could infer that some string was supposed to be a string. So implicit types is the very beginning of TypeScript, where as long as the compiler that TypeScript comes with can understand and read and parse your code in basically, if you've written it in a way that it's knowable what type something is going to be when you initialize that, TypeScript, you don't have to add anything, and it will just compile if you do something that doesn't make sense. When you start adding things that are no longer JavaScript, this is the first thing that we've looked at that is no longer JavaScript. The general syntax is this colon and then the type annotation that you want. The most basic might be a string. So some string, I want it to be a type of string. And if I try to set it to 2, TypeScript's going to yell at me because it's going to know this is not a string. So here's the summary of those basic explicit types where you're telling TypeScript what you want. We have the string. We have a number. Then we have an array. So the syntax for an array is pretty straightforward. The curly, the brackets representing an array, and then the type of thing that you expect to be inside of that array. That way you can be sure that you're, in most cases, you don't want like some string and then an object. And you'll notice that this is, obviously, it's not JavaScript here, but it's very unobtrusive, I think, is a good part of the justification for TypeScript's popularity. And then I can also indicate an object. So I'm saying here, some object needs to have this shape. And I think that's something we'll be talking a lot about, is shapes in TypeScript. You want to tell the compiler what the shape of your data is, so that the next time you access it, you already have autocomplete and you know exactly what, as you traverse down an object, what the options are going to be. So in this case, I say that in order for this to be allowed, the object needs to have a key as a property, and the value for that property needs to be a number. So when I initialize it, which is normally we would just write this some object equals, now we've added this intermediate steps of make sure it looks like this. When I initialize it, that's how it's going to look. Okay, so let's attempt a simple demo. Yeah. Yeah, of course. Thoughts on that?
Great.
Cool. Yeah, let's go here. So this is the demo that this is the set of things that we just looked at for explicit types. You'll notice here that some string is a implicit type, right? There's no colon here. So I can do this, and it's not, it's obviously not based on the name of my variable. So this is just fine, because I haven't told TypeScript what I want it to be. But if I say a type of string, and then I try to set a number, it's going to yell at me, and it's going to give these really helpful, wonderful, beautiful error messages. Another reason for TypeScript's popularity, I think. So it'll tell you straightforwardly, this isn't allowed. Now a number, if I try to assign anything else to this, it's going to yell at me, it needs to be a number. Array, similarly, I said this needs to be an array of strings, so if I try to put a number here again, it'll yell at me, not assignable to type string. I can do, obviously I can do anything here. I could make it a number, or I could even make it an array of objects, or however you want to annotate this. And we'll get into some of the more detailed types that you can do. Finally, when I say this has to be an object, the really great thing here is we see the very beginning of TypeScript's autocomplete. So I'm going to start typing. If I type something that doesn't match, then VS Code is just going to start guessing, like, could you possibly mean these things? But if I type something that I've said, hey, this needs to be on the object, I'm going to get autocomplete, and it's also going to tell me that's allowed, that's not allowed. So just really, really great, really straightforward, and excellent error messages. Now we have methods. So this might look a little more different. Now it's kind of two things that we're adding. So increment by one is just a method. The normal way we would do this with arrow functions is increment by one equals whatever the parameter that you want is, then the arrow function. This is the ES6 arrow function, and then whatever we want the function to do. In TypeScript, you want to annotate both the type of parameter that it's going to take, which is right here. So normally we would just have start here, but we're annotating what start can be, what start needs to be. And then at this point, we're annotating what the function is going to return. So we can take a look at our demo here. If I want to use this increment by one that I've set up, and I say that that I'm expecting this constant that I want to increment the number 1 by 1, and I want to set it here, but I'm expecting a string. So I'm saying this 1 plus 1, it needs to be a string. It's going to yell at me because it knows what the type of increment by 1 is. It knows that it takes in a number, which we're doing, but then it's supposed to output a number, and so these things just don't work. If I set this to number because that's what I'm expecting it to be, then everything's good. And just as a quick review, here's a case where TypeScript can figure things out for you. It knows what this returns, takes a number, returns a number, and so when I hover over 1 plus 1, it knows, hey, this thing is a number because that's what the method's returning.
Which thing would you write if you were actually writing code?
Yeah, I would write this. A good rule of thumb, maybe a good rule of thumb when you're starting is to make sure you understand what the types of things are. So you can over annotate. I'd say that's fine. You can say, okay, while I'm thinking about this, I know this needs to be a number, so let's just get it out of the way early. But as you're going forward, you can do the exact same amount of error catching when you recognize, oh, TypeScript is going to know in this case. Like, there's nothing complicated about this. There's no uncertainty. And so to save time and make it slightly more concise with the exact same amount of type safety, I would write this way. Now we get into the, I guess, higher level type annotations that TypeScript provides. So things that aren't just in the form of colon, some basic annotation of the basic JavaScript types. Now we start to have ways that TypeScript gives us to define the shape of something in a slightly more complex way. The most common one that we'll be looking at today, and that I think you'd be using in a lot of your Vue code, is an interface. And an interface says, this is the shape that I want something to be. All these things that we've looked at so far, including interface, have no existence once the code is compiled. So you write it, and then you say, npm run build. Often this happens with Webpack after the TypeScript compiler runs, but you say build, and all your TypeScript code goes away. None of it is shipped because a browser doesn't understand what this interface is. There are a couple things in TypeScript that will leave you with actual code, but again, the thing that gets output is always JavaScript because it has to be understood as JavaScript. So this is a way to say when I'm using some method, I expect it to have this shape. So I have my member interface here, and this is the way I know that when I'm using this bit of data, I know it needs to be this shape, because you can imagine somewhere down the road, 2 directories deeper and in 3 different files, something's going to be expecting a parameter to be passed this way or a function to return this type of thing so that it can access properties that you're expecting to be there. So you need to say, yep, this is the shape of it. So, so I'm creating this new constant. Often, this is something we can review as we go along. Often interfaces, just from a code standards perspective, will be capitalized. They'll be Pascal case, so capitals, and then you keep your JavaScript variables the same. So camel case, so member something, right? So I'm creating this, and I know that this is the shape it's going to have. So if I were to do this somewhat from scratch, it would look like this. I know, okay, I know it needs a name. I can't, there we go, there's name, some name. You'll notice some of these are going to be politically themed, given Politico. Now I think there's an ID, and I get the ID that I need to have. And now I know that office is itself an object. So I start typing office, and I set it up, and it's still not valid because I've said that, hey, this office needs to have 2 more properties, an address and a staffer count. So there's my address. And finally, there's my staffer count. And we finally get to no compilation errors because I've provided everything that I said needs to be there. Something else that we can come back to later, if I think that staffer count could be there, but it's not essential, TypeScript gives us the really simple way of saying optional. So this essentially takes this type that you said here, so it can either be a number or it can be not passed at all. It can be undefined. So then when I remove this, we are now okay because I've said staffer count is optional. So that question : syntax can be very useful. Okay, I think we just have hopefully just 2 more, I think, in terms of TypeScript types, and then we'll do some quick questions, and then obviously we'll get to the workshop. So I mentioned that most things in TypeScript go away at the time you build. That's true for interfaces. That's true for the other type annotations we've seen. It's not true for enums, and enums are an interesting syntax or convention that is at least very popular in Java and C#, and that's about where my backend knowledge ends. But it's a way of saying, I want to identify something, and I don't want to use a constant. Because we often do this in JavaScript, we think that the closest we can get to avoiding typos, I guess, is I'll capture all my kind of arbitrary values where I want to identify something. I'll capture them in constants. And then every time I want to access something, like I'll say member slug is a constant, so that I'm not typing, Nancy Pelosi every single time because I've saved it in one place. Enums are a significantly safer way of doing this, where you're capturing your arbitrary information that's used to identify things. So it looks like this. In this case, I have different office types. And the best way, I think, to show how this ends up getting used is in a demo. So I have my office type enums, and there's going to be this situation over here where I don't know, because I've set it up that way, I don't know whether what the office type is going to be, and I still need to make a comparison against it. So rather than saying is the office type 1, is it 0, is it representative as a string, I can compare very safely to know in my if statement which one it is. So I have Pelosi's office type, I'm saying it has to be of this enum. And then here, I'm just going to set it. So because it's random, we don't know which one it's going to be. And then down here, we're going to log which one is it. And so normally, this would look something like district office, right? Like you've just set up some arbitrary slug previously, and you hope that you don't mistype it, because if you do, this is never going to be true, and that's definitely not what we want in our code on the browser. But I get this helpful message from TypeScript. This condition will always return false since the types office type leadership, office type district, and district office have no overlap. It knows exactly that this isn't a comparison that you're allowed to make, and it's definitely going to fail in the browser. So instead, I get my lovely IntelliSense office type, and then this is where it's tough to it's tough to convey how great this type of thing is when you use it over and over and don't have to worry about manually typing out constants. But I know, and you can imagine, your API response has 7 different types of offices, and you're worried that you're not typing it correctly or you've forgotten which ones are available. But here I just know, okay, it's going to be an office type, and here are the options it's going to be. So then I go ahead and it works just fine. Enums have existence at the time of compile. They compile to an object so that you can make these comparisons at runtime. There needs to be something there to help you make the comparison. And there's also some really cool things you can do where you can get the label of an enum if you access the individual member of the enum. Not doing a great job explaining there, but there's some great stuff you can do with enums. They're very powerful. And then the final one that we'll mention is type. So a type in TypeScript is pretty much anything else. And a big example that you'll see a lot is something like this, where you say party, it can only be any of these strings. And so you make sure that when I use party, I am saying it has to be one of these 3. And if I mistype, then it's going to tell me Democrat is not assignable to type party because it's not one of these valid options. If I were to go back to a valid option, then we're all good. So this type right here, we're just showing unions of strings. You'll see it used a lot when you need to compose something more complex in describing the shape of your data. Whew. Okay. So initially, I put on a version of this talk at Politico as we were getting started with TypeScript, and from our perspective, these things here, and I'll certainly obviously share the slides. I can probably do that while we're working here. These additional options that TypeScript gives you are very powerful, used in some really interesting and complex ways, and also you don't have to worry about them right now. With everything that we talked about, that's plenty to get started with your application. One thing I'll mention, because it comes up with Vue, is that we didn't talk about class. JavaScript, and because of that, JavaScript frameworks now have the concept of a class and previously didn't, with all the good and sometimes confusing things that come with that. Really important in a lot of object-oriented languages and things like dependency injection, and that was huge for Angular as a framework when they started using TypeScript. They're all classes all the time. Classes are also used to show the shape of something, but they too have existence at the time you compile and have a lot of interesting and cool functionality. You may have heard either in Vue or in React, there's the same debate in both. You can create your components with classes or without classes. And that's been around as a discussion point because there are certain things that work really well with classes and then certain things that work better or more simply maybe with functions. So the way you'll always see Vue documentation is the function or the object syntax for creating a Vue component. As you look at TypeScript documentation, if you try adding this to your project, you'll see that there's also documentation about how to do Vue components with classes. And there's definitely nothing at all wrong with that. We chose, yeah, please.
So are you following your GitHub thing, how am I to get repo repository?
Yeah, not yet, but I will be shortly.
So you have like a TypeScript one thing. My question is,
Yeah.
I've had issues running TypeScript before in Vue.js because some dependencies, some library I'm using,
Yeah.
don't work fully in TypeScript. And another little command you have in your repository basically converts everything to TypeScript.
Yeah.
But if you have dependencies that are JavaScript only.
Yeah. Good news is you can always import any JavaScript dependency can be imported into TypeScript code without an issue. There may be times when you get frustrated if you're using a JavaScript library. Like I would like to be more confident about the types here. I lose some of my type safety at the time of compiling. If you're one we've come across is Lodash has some methods which have great types, but there are certain things in Lodash where it's taking in strings and converting those things to objects, and there's no way for TypeScript to know what that string is actually representing at that point. So there may be frustrations, and we'll look at in Vue, there are certain things in the Vue CLI that we're expecting JavaScript. And those are mostly lint and build configurations that we're going to try to work through. But I would say the overall summary is any library that you're importing and using some methods on it from NPM, you can always use it in TypeScript. The only risk is losing some of your type safety, where you can say, I always know what's going on, or in this case, I may not actually be sure what my types are. We already went over most of this, the object and the class. Our preferences for Politico, but it's really just because object matches up with what we have already been doing, since class is a TypeScript only syntax for developing components. I think the two main limitations that I've made notice of here, is that when we're going to do TypeScript in Vue, there are some things that are handled by. Sorry, the quick poll question. How many of you are using VS Code? Cool. That's also a very common trend. Yeah. I didn't want to ask that. It's great. Works super well, obviously for Vue and obviously for TypeScript. Most of us then are using an extension in VS Code called Viter, which is how we can write single file components where we have our template and then our script and then our style. And so you have three types of languages in one file, and so you need an extension to deal with that. And that, I would say, is the biggest limitation that we've come across. It's slightly less perfect, I would say, than writing pure TypeScript files, because Viter has to implement things to make sure it can actually read the TypeScript in these single file components. But they're always making improvements on that, and I would still say that our experience has been really, really good. Okay, so that being the introduction. Would love to hear if you have any questions at this point, things you didn't understand or questions you had coming in that you feel like you should have understood by now, but I did a bad job of explaining it. Anyone thinking about anything? Cool. All right, let's give it a shot and see what breaks.